Explain what you understand by a population. A population is all the required data. Question number B, statistic. A statistic is a random variable. It is a function of the sample which contains no unknown quantities. A statistic is the calculation made from sample, and it is mean, standard deviation, median. All these things are called statistic. It can be used as a random variable, and for calculating the statistic we don't need any unknown quantity. The next one is question number C. A researcher took a sample of 100 voters from a certain town and asked them who they would vote for in an election. The proportion who said they would vote for Dr. Smith was 35%. State the population and the statistic in this case. The population is what you need. All the required data is all the voters. So the population is the voters. So all the required data is population. Now the statistic is the calculation that you make. It's a calculation. So here the proportion, the statistic is the proportion. Next question, explain what you understand by the sampling distribution. So sample distribution is a probability distribution where the random variables are the statistic and the probabilities are given below. So that's called a sampling distribution. It is the probability distribution of those voting for Dr. Smith. Remember, you have to give context. If you give no context, you get no point from all the possible samples and their probabilities. So each and every random variable and their probability, that is the sampling distribution. In question number 2, Bhim and Joe play each other at badminton, and each game independently of all others, the probability that Bhim loses is 0.2. Now you know it is either going to be binomial or Poisson distribution. This is probability 0.2. It has to be binomial distribution. So the probability is given and this is also given. So this is n. So find the probability that in 9 games, so that is n. Whenever you see probability, it has to be binomial. Exactly 3 games. So how do we start? We always start by defining the random variable. X equals to number of Bhim loses. So number of games Bhim loses, that's the probability of success, and the distribution is going to be n is 9. There are 9 games and the probability of success is 0.2. Success or failure is not about a good or a bad thing. Whatever is given information, that is success. Exactly 3 of the games Bhim loses, therefore probability of x equals to 3. So this is discrete. It is going to be probability of x is less than or equals to 3 minus probability of x is less than or equals to 2. Look up the table and write down the answer. The next question, the probability that Bhim loses fewer than half of the games. Fewer than half, that means if they play altogether 9 games, fewer than half means x is less than 4.5. Since this is discrete, less than 4.5 is going to be x is less than or equals to 4. That's it. So look up the table. That's it. After that, we are going to have Bhim attends coaching sessions for 2 months. Okay. After completing the coaching, the probability that he loses each game independently of all others is 0.05. So the probability now is very low, 0.05. Bhim and Joey agree to play a further 60 games. So now now the probability of success is very small and the value of n is large. Remember, larger than 50, that is means this is not in the table. Calculate the mean and variance. So mean means expected value. Now if I write ex, it would be wrong because x is for n is 9, p is 0.2. So be careful about that. Instead of writing ex, it's best to write just mean and variance. So don't fall into this trap. Mean equals to np and variance equals to n p 1 minus p. This is 2.85. Okay. The next one, use a suitable approximation to calculate that beam loses more than 4 games. So more than 4 games means it has to be, first of all, we have a new distribution to do, because it is not possible to do the sum under this distribution because the distribution has changed, and they always mention this, using a suitable approximation. So we can use y. Since both of them are same, you might not write this all over again. If you want to, you can write it. Number of games beam loses, so it is going to be y 60.05. that means we have to do a distribution. Now you can see the mean and variance, they're close to each other, so that means we can definitely use the Poisson distribution. Lambda is 3, so using Poisson approximation, so we can write the alphabet A, Poisson, lambda is 3. Now we have to find the probability loses more than 4. Let me write over here, probability of A is greater than 4. That means probability of A is greater than or equals to 5. That means 1 minus probability of A is less than or equals to 4. The answer is 0.1847. A rectangle has a perimeter 20 centimeters. So whenever you read that, you understand this is neither binomial nor Poisson distribution. This is a uniformly distributed. So when you do this uniform distribution, you have to understand this is a bit irregular. Uniform distribution is not something that we get in all of the exams. So what they have given, we have a rectangle. So this is a rectangle. One of the side is x. Suppose the other one is y. So the length x centimeter of one of the side is uniformly distributed. So this is uniformly distributed. So we can say that the perimeter is 20. So x, if this is x, and this is y, this is y. Perimeter means total length. So x plus y plus y equals to 20. That means 2x plus 2y equals to 20. That means x plus y equals to 10 if I take 2 common and divide. So now we are talking about this one, x. If x is between 1 and 7 centimeter, if this is the interval for uniform distribution, so if x plus y is, if two of the sides is together 10, if one side is 1, if one of the side x is 1, then the other one must be 9. So, and the other way around, if one of the side is 7, if both of them together is 10, it should be 3. So the distribution is 3 to 7, and the PDF is going to be, the rule is 1 by b minus a, which is 1 by 6. So the sketching for this continuous uniform distribution, this is x, this is fx. So the limit is going to be from 3 to 6, and the PDF is 1 by 6. Since it is uniform, it is going to be like this. Okay, now find the probability one of the longer side is more than 6 centimeter long. So the probability for more than 6, so assuming we are talking about x, because one of the side, find the probability that the length of the longer side. Now we do not know which side they are talking about, either x or y. So suppose we are talking about x, so more than 6 means this one. If we take this as 6, so this to this is 3, this is the area we are talking about. So the probability of x is greater than 6 is equals to area, length into breadth. So this is 6 to 9 is 3, and this is 1 by 6, so this is half. Now one of the possibility is, if this is more than 6, it could either be x or it could be other side is 6. In that case, x is going to be 4. You have to remember, if this is together is 10, if this is 6, then this is going to be 4. So, or it could also happen, so probability of x is less than 4. In that case, if it is less than 4, if it is here, so this is the probability we are looking for, which is 3 to 4 is 1, and this is 1 by 6, this is 1 by 6. Therefore, probability of more than 6 is either half or 1 by 6, which is 2 by 3. This is irregular, but this is extremely irregular sum. This is not something that you do in every paper, but this is something you might want to review.